of modulus x plus y when x squared is 4 and y is 1. First piece of information we need to identify is that x squared equals 4, which means that x would equal plus or minus 2, taking the square root of both sides. Therefore we have two different options for x, one for y. So we take both of those two separate options. So we say 2 plus 1 is 3, and negative 2 plus 1 is negative 1. However, it's the modulus of this expression. So therefore my two answers are 3 and positive 1. The next one, f(x) is that gx is that, find g2, so that it means that we're substituting the value of 2 into this expression here in place of the x. So it's 3 times 2 squared plus 1. 2 squared is 4. 3 times 4 plus 1 gives 13. G of f of x. So that means we're putting f of x into g. Similar way that we inputted 2 here into g, but this time we're inputting fx into g. So we've got 3 lots of 2x minus 1 squared plus 1. fx is here. That's what we've got in place of the x in that expression. As it says there, no need to expand and simplify. We can just leave it like that. Find the inverse function of fx. So to find the inverse function, write y equals, and the function, so in this case it's 2x minus 1. We then switch the x and y, and now rearrange so that y is the subject. So x plus 1 equals 2y, so y, f dash 1x. Let's do this here. Y equals x plus 1 over 2. That's x plus 1 over 2. Number 3, solve the equation. Okay, so this is the non-calculator, but we can see that it's a quadratic equation because it's got x squared. So it means that everything has to be moved away from the right hand side, so we have to equate it to 0. So we'd have 2x squared plus 11 minus x minus 21. Putting in the normal order we would have, it's descending powers of x, so it's 2x squared minus x minus 10. So we're now factorising, or you could use a quadratic formula. I would suggest factorising myself would be easier. So to factorise, we multiply first and last term. We use that negative 20 to split this term. So I know that that's negative 5 and positive 4. So we've got 2x squared minus 5x plus 4x minus 10. So just to confirm, the negative 5 and the 4 has come from the fact that they multiply to give negative 20, and those two numbers add to give negative 1. Having established what goes in the middle, we cut the expression in half, factorise both separately. So on the left hand side, all that's common is x, and on the right hand side we can see that 2 is common, positive 2, and luckily we have the same bracket, so our bracket is now common, and we're left with x plus 2. Remembering that these are all equal to 0, that means that our two solutions are whatever makes this bracket equal, whatever makes this left hand bracket equal to 0, and whichever value makes the right hand bracket equal to 0. So that would be negative 2 and positive 5 over 2. So if we were trying to find this one, it would be 2x minus 5 equals 0, 2x equals 5, x equals 5 over 2. Similarly, x plus 2 equals 0, x equals -2. Okay. Moving on to number 4, we've got two graphs and we have to identify which of the functions it's going to be. Hopefully straight away you will notice that D is out, as is H, because neither of those are sine graphs. My hope is that you would identify that this is a straight line graph, so we're looking at something in the form of y equals mx plus c, and this is a parabola, so we're looking at something involving x squared. So essentially that wipes out all of them, which makes this one graph A and this one graph C. This one would be A because we can see our gradient is -2 and it has a y-intercept of 4. So the 4 obviously is up here and it's a downhill slope which links in with a negative gradient, and this is the only quadratic, so therefore that's the only parabola. Okay, moving on. This one I mark quite harshly. I'm assuming they will do in the real exam as well. Lots of people recognize that this 2 changes or stretches it vertically. What you have to be careful with is that the x values don't change when that happens. So it's still going to go through these 2 points here. All that's going to happen is that where the original distance from the x-axis was this value, this amount, it's now going to be twice as high. So it's going to cross at around here, but still go through those green x-intercepts. So we're looking for a parabola looking something like that.